Mika, is it audible to you?
Yeah.
Yeah. So how are you?
Yeah, I'm good. How are you?
I'm all fine. Okay. So we were doing the mole concept. You got
Yes.
the questions. You got the questions.
Yeah.
You received the mail.
Yes, I did.
Mail. You
Yeah, I
received.
did.
Okay, great. So that is already one type of mole concept is over. Another type we are reaching here. That is a mole concept for. Here we are going mole concept.
But I couldn't solve all the questions.
Okay. Yes. Wait. So, how can you share that one? How can you share that questions? Can you?
It was problem number 3. So
Hmm,
in the PDF,
okay.
um, number 3 and 6.
Mhm,
Wait, I'm opening it.
mhm. Problem that I need to find that for those problem also. You are saying problem number 3. How many hydrogen atoms are contained in 1 mole of ethanol? This is the questions, no?
Yeah.
Okay, good. So that is third number I am doing here. See here. They are saying how many hydrogen atom? They are saying if I write that is how many H atom present in 1 mole of ethanol. 1 mole of ethanol C2H5OH. Right. This is here. So I told you how to calculate number of atom. So there are so many formula till now we studied. Okay. So number of atom n is equal to we apply n into Na. This is okay. Keep in mind. So this is the second rule. This is the rule number second, rule 2. So number of atom. If you talk about this one, this is the Avogadro number. Avogadro number. And here is they are talking about uh, this is the number of mole, and here they are talking about the number of atom. Okay. Now what the problem is here? Here is atomicity is different. So one more rule I told you. Okay. So here is n is equal to we told you number of H atom, specific atom, H atom in one molecule, atom in one molecule. So firstly we are going to calculate number of H atom in one molecule. Then what we have to do? Then simply we have to multi n into Na. This is okay, simple, very simple. So this is what is known as number of atom in one molecule. This is also known as atomicity. No? So this is
Yeah.
you can multiply atomicity. Okay. Atomicity of H hydrogen. Okay. Multiply by small n into Na. Now let us try to understand. Here is n is there. So atomicity, how many hydrogen atoms are there in this molecule? One molecule. This is the one molecule, na? C2, no, atomicity of H. You
Yeah.
see atomicity of H in how much in C2H5OH. So you can check it out. How many hydrogen atom are there? Here is 5 hydrogen, and here is 1 hydrogen. So total hydrogen atom is how many are there? 6 H atom. Yes, yeah, no? 6. So in one molecule 6 is there. Okay. So total number of molecule, that is n into Na. So here is 6. How many mole they are saying? 1 mole. So n value is 1. Na value you know very well, 6.022 into 10 power 23 atom. And which atom? That is H atom. So now try. So if you are multiplying, so it is going to 6 to the 12, 6 to the 12, 1, 13, 6, 6 the 36. 36.132 into 10 power 23 H atom. Is it objective? Yeah. So you can put the decimal this side. So it will going to be 3.6 into 10 power 24 H atom. So option number is which one is option D is correct. Are you be able to understand this?
But what I don't understand is that how did we use the atomicity of H
Hmm.
and use the like 1 mole, because it says that there's 1 mole in the whole, like 1 mole of the whole ethanol, right? So how did we just, shouldn't we find the number of moles of the hydrogen in the ethanol?
Okay, I think you a bit confused. Okay, you firstly you see C2H5 is there, C2H5OH. Okay, number of hydrogen atom, if you are talking about number of hydrogen atom, okay, number of hydrogen atom in one molecule. If I am talking about one molecule, molecule means single molecule. So how many are there? You can count it out. 5 hydrogen is here and 1 is here. So 6 hydrogen atom. Is it clear? Up to here is okay?
Yes.
Okay, very good. So suppose one molecule contain how many hydrogen atom? One molecules contain 6 hydrogen atom. Contain 6 H atom. 6 H atom. So if I am asking 2 molecule, how many hydrogen atom will be there? 2 molecule contain how many?
12.
12 hydrogen atom. Very good. Thank you very much. So if I am asking, that is, if I am having the molecule 6.022 into 10 power 23 molecule, okay, 23 molecule. So what I will do? What should I do?
Multiply 6 by 6.022 times 10 to the power 23.
So 10 power 23. So how much is coming? 3.6 into 10 power 24. H atom is coming. Okay. And one mole molecule, if you are talking about, 1 mole molecule is equal to how much? 6.022 into 10 power 23 molecule. Yes or no?
Yeah.
So they are talking about, that is, you see the questions, they are saying how many hydrogen atom present in 1 mole of C2H5OH. So C2H5OH means this is the molecule only. This is the molecule only. Getting my point? So 1 mole of molecule means that is Avogadro number of molecule. So Avogadro number of molecule means simply we multiply. Are you be able to understand now?
Yeah, I understood now.
Okay, good. Let me know which one is the next one. Which one is next?
No, because they were all the same type of question. I didn't know how to find specifically the number of moles of one part of a whole molecule.
No, what you
So
can
they're all the
do,
same.
what you can do, if you can share question number also, na? Question number, you take the pick, okay? Either you write down in the mail itself, this is the question, you can type the question. Anyhow, you know how to use the mail, yes?
Yeah.
So just simply type the question or the send the question number or anything, what you can do, just to convey the message anyhow, okay? Getting
Okay.
it? Otherwise, I don't know you people are using the WhatsApp or not. You people are using the WhatsApp.
Yeah, we can use WhatsApp.
So can I give my WhatsApp number? You can directly share to me. You want?
Okay. Yeah.
Okay. So I'm writing. This is the number. So on this number, this is the WhatsApp number. So directly you can share the question number. Okay, immediately you can share. I'll solve. I'll send you back.
All right. 7 seconds. Okay.
So what I'm doing, I'm proceeding for today concept. Okay, because if we stuck in the last day lecture, it will be very slow process. I don't want to make you slow. I want to make you racer. Okay, so you are in the suppose you are fighting, running participating in the Olympic, wrestling Olympic. So that is what you be that much of speed. Whatever it is lagging, just you send me through WhatsApp or through mail, whatever the convenient is there. I am ready to help you. So simply I'll solve and I'll send you. So you will 100% you'll be able to understand. Got it?
Okay.
So that is what the today concept I am giving you, and I'll save the problem also. Little bit you spare the time on the solving the problem, because mole concept is tough topic. It's a numerical base. So a little bit you will take the little time to tune up with the problem. Once you are started imagining and thinking about the problem, it will be all the problem will be solved. So okay, let's solve today concept. So today, if you are talking about the today concept, that is, I told you mole concept. Okay, mole concept in gaseous system. Okay, gaseous system. Till now we were given, that is what we were given, that is given mass is there, mass in gram is given. Okay, so here what will be there, if here na, if volume is given, if volume is given, if volume is given, okay, given, then calculation of mole, then calculation of mole. Okay, they are saying calculation of number of moles. This is what, if volume is given, then calculation of number of moles. If volume is given, then calculation of number of moles. This is what the case. Earlier what we were studying, that is how much it was there, no, that is given mass is there, then we are calculating molar mass. Here is the concept is little bit different. That is, volume is given. Suppose I am having the room, or we are having the, suppose, bottle. Okay, so this bottle they can ask, that is how many gaseous molecule is there. Okay, so for these cases we have to understand, that is how to calculate. So first case, you see here, you see that is 1 mole of gaseous, no, gaseous volume. Okay, gaseous, okay, volume, no, 1 mole of gaseous volume, how much contain, how much contain. Okay, 1 mole of gaseous volume contain 22.4 liter, 22.4 liter. Okay, yeah, 1 mole of gaseous volume have, you can write like that, have how much, 22.4 liter, or you can also write on 22.4 decimeter cube. That is also the same concept, dmq means same. Now let me tell you what is meaning of. Earlier we were talking about 1 mole. If you are talking 1 mole molecule, if you are talking about 1 mole molecule, it was that is 6.022. It was coming 6.022 into 10 power 23 molecule. Okay, 1 mole is equal to this much. Now here they are talking about 1 mole gaseous volume have how many liter, 22.5 liter. This is the what the fundamental things that you have to keep in mind, that 1 mole is equal to 22.4 liter. That is, Acha, in India, suppose in India what is there, we consider that is 22.4 liter. In other countries, somewhere they also use that is 22.7 liter. Okay, so you need not to be confused here. You need to see that is in your syllabus what is there. In your syllabus what is there. Generally, the concept I am telling you. Okay, little bit wait for the concept. See, have you heard about PV is equal to nRT? Have you ever heard about this equation?
No.
No. Okay. See, here is the boy. It is the, I'm talking about the, in India, what we use the NTP, or we use the STP. In the other country like that, whatever the other countries, they are using that is RTP. Okay, RTP. The same term is there. N for that is what is known as, if you are talking about normal. Okay, T for if you are talking about temperature. Okay, normal temperature, and P for going to be pressure. Okay, this is pressure. If you are talking about this one, if you are talking about this one, so this is going to be standard. This is going to be standard. If you are talking about T, so this is going to be temperature. If you are talking about this one, so this is going to be pressure, right? So standard temperature pressure or normal temperature pressure, they are the name. Here they are the, in your places it is called something they call, that is, this is the pressure, this is pressure. T for that is temperature, and R for room. They said that is R for room. So all the places that is the thing are the same. Now, if anyone is asking what is NTP, normal temperature pressure, what they are talking about, STP, standard temperature pressure. There is any difference? No difference. If they are from what is the RTP, room temperature pressure, that's same. Now they are saying from this one you can calculate V is equal to nRT by what? nRT by P. So here from this one you can calculate that is volume. So if you are putting that is 1 mole, I am talking about 1 mole. Okay, R value is 0.0831. Okay, temperature is, you can take 273.15. Okay, here your pressure is, you are taking 1 bar. Okay, so if you are solving this one volume, it is going to come 22.4 liter. Okay, 22 point means volume of 1 mole of gas. How much mole you have taken here? How much mole you have taken? 1 mole. So volume of 1 mole of gas is how many liter? Can you tell me? 22.4 liter. Yes or no?
Yeah, okay.
Okay. Some places this is also they mention, that is some places what they mention, that is 22.7 liter also, but they are the little bit after point, this can be considered. Okay, why consider? If I'm asking, the reason is what, Janab? That is actually I'm teaching daily. One girl is there. Her name is Janab. So her name is strike more faster than the your name. So Mika, here you see, P is now P is, that is called 1 atm, atmospheric pressure, ATM. That is unit of pressure is 1 atm, ATM, or that is equal to 1 bar. Okay. Now sometime what they do, 1 bar is equal to 1 bar means what? The real value 0.987, 0.987 bar. If you are putting this value, na, this approximation, so this value will come. Okay. But what we do, in spite of writing 0.987, what we use? 1 directly, we are using 1. So if you are using 1, it will come this value. If you are using 1, so this value will come. Got it? What is difference between 22.4 and 22.7?
Not really.
No. What I'm saying, see, okay.
So if you use the approximation, then you get 22.7. If you don't use the approximation, you get 22.4. Is that it?
Yeah. Got. Good.
Okay.
Approximation, if you are rounding off, approximation, so 22.4. And if you are taking that is absolute, if you are putting the absolute value, absolute value 22.7. Got it?
Yeah, okay.
Okay. So if someone is asking that is what is different between these two, so you should know that you can tell that is actually pressure is, atmospheric pressure is 0.987 bar. Actually it is 0.987
Yeah.
bar. But to calculate, to put in the calculation 0.987, it is very difficult to multiply. So what we use, simply we use the approximation, that is 1, rounding off. Yes.
Yes, okay.
So if you are using 1, so it is going to give 22.4 liter. If you are using the absolute value 0.987, it is going to give 22.7. So what we are going to use here, 22.4. Getting my point?
Yeah.
Okay. So here you go. 1 mole of gaseous volume has 22.4 liter or 22.4 decimeter cube. So this is the what the our basic. Hello.
Hi. Okay. I think I got exited from the meeting.
Yeah, I think something problems happen. I think network issue or something. Yeah. Okay.
Yeah.
Extremely sorry. Yeah. Okay. So 1 mole gas, if I am asking, that is 1 mole gas volume is equal to how much? Can you please tell me? 1 mole gas volume is equal to how much?
22.4
22.4 liter. Yeah. So this is what the case. Up now, 1 mole gas volume you got to know. Okay. So if I am asking, that is calculate the, now you see, calculate the number of, okay, calculate the volume of, writing, I'm writing, calculate the volume of, okay, volume of 2 gram, okay, 2 gram of H2 gas at STP? Tell me. This is the question. Question they are saying A number option they are saying 11.2 liter. B number option they are saying 22.4 liter. Okay, C number option they are saying you can say 44.8 liter, and D option they are saying none. So what can be your answer? Yeah.
22.4 liters.
Which one? Which one? Which one?
B,
How? How?
because we calculate the number of moles, which is given mass over molar mass, which is 2/2, which is 1. And then we have 1 mole of H2 gas, which is 22.4.
Thank you. Yeah, good, great, great. Okay, let's have one more question. Calculate the, okay, simple, I'm going. Calculate the number of, okay, either, this is the type 1, na, you please don't get confused. This is what we study, this one is type 1 problem. This is the type 1 problem. Type 1 problem, what can be formula? Okay, now they are saying calculate the volume of the volume. So how we are calculating? N is equal to given volume, okay, upon that is molar volume. Okay, this is the formula. Now this is going to be capital N. This is the N. This is the for gaseous. Small n is equal to given volume upon molar volume. Or you can write that is n is equal to given volume. We have to calculate. Molar volume means 22.4 liter. Okay. So if someone is asking what is the volume, okay, what is the volume? So what we can write n into 22.4 liter. Can you apply this formula? That is what you did. Firstly, you calculated the n value. Given mass over molar mass 22.4. Yes, no? This is type 1.
Yeah.
Okay. So now we are moving for the type 2. Okay. So if I will go type 2, see the what is the type 2? Type 2. So type 2 means this is what calculation of number of atom. Calculation of number of atoms. Number of atoms. This is what they are saying. So question is there, calculate the number of hydrogen atom, H atom in 44.4 liter, 44.8 you see. 44.8 liter of H2 gas. This is they are saying. Okay. So they are asking number of hydrogen atom in 44. Yeah, it can be, wait. So, yeah, correct only. So they are asking number of hydrogen atom. What can we do? This is the given volume. Okay. So just now I told you. So what we can do here, you see solution. Okay. Solution I'm telling you, little bit you patiently. Number of mole. Okay. Number of moles of gas means what we can do, gaseous volume. So gaseous volume is equal to what is going to be given volume. We have to see given volume divided by what we have to do, molar volume. It's very simple, as like the previously what we are doing. Okay, so you see that is N is equal to, we can write that is given volume GV upon molar volume, that is what 22.4 liter. Can I write this one?
Yeah.
Molar volume means 22.4 liter. That is very simple. Yes, can we write?
Yes, yes.
Okay. So see, N is equal to, see, what is there? Given volume is there, this one. Calculate the number of hydrogen atom in 44.8. So can we mention it here 44.8 upon what we can mention here 22.4 liter? Yes, yeah, no. 22.4 liter. So here is downside liter, upside liter. Liter is cancelled out. So value will come into how many? 2 mole is coming. Yes, yeah, no.
Yeah.
So okay, good. So that is N value we got how many? 2 mole. N value is 2 mole. So number of H atom, how to calculate number of H atom? So that is number of N is equal to atomicity, atomicity into small n into Na. Okay, because hydrogen exists in this form. What one? H2 form. And how much moles we are having? You can see 2 mole H2 gases we got. So what will that is? What is the atomicity of H2? Can you tell me atomicity of H2?
2.
Okay, thank you. Atomicity of H2 is equal to, it is going to be 2. So here what I am writing, that is 2. Number of mole you got 2. Na value 6.022 into 10 power 23. So how much will come? 4 into 6.022 into 10 power 23. So you can multiply 880 and 6 4 ja 24. 24.088 into 10 power 23 H atom. So although you may find difficult, but it's enough interesting to learn. Can't you understand this one?
Yeah,
Can I erase or are you writing?
I'm still writing. Wait.
Okay, no problem. You can take time.
Okay, I'm done.
Okay, good. Okay, let me erase. One more question I'm giving you here. You see that you solve by your own. Okay, this question they are saying calculate. They are saying calculate the volume of volume of CO2 at STP or RTP. Okay, room temperature pressure, RTP, volume of CO2 gas. Okay, they are saying at STP or RTP for 0.20 mole of it. So option I am writing 4.8 liter, 2.4 liter. You please write down this one. Tell me the answer. 8.6 liter. None.
Okay.
Hmm.
Calculate the volume.
Done. This is the formula which you have to use. See, now I am telling you a little bit. Number of mole is equal to number of gaseous mole. Okay, gaseous mole. So you can add given upon mass upon molar mass, but given mass is not there here. What is there? Mole is there. Okay, but STP is there. STP. So what is number of gaseous mole? How we can calculate? that is it can come given volume, okay, given volume, and given volume upon molar volume, as like molar mass na, this is the molar volume for all the gases. Molar volume is same, 22.4 liter. Okay, this is the fix. So N is equal to given volume upon what, molar volume, or in bracket 22.4 liter, this is there. So we need to calculate N value they have given here, you see N value they have given, no, 0.20 mole. Okay, so we can write 0.20 is equal to given volume, that is what, calculate the volume, okay, divided by 22.4 liter. So that is give cross multiply, here nothing is there means 1, you can cross multiply. So what you are going to get, given volume is equal to 0.20 multiply by 22.4, you can multiply. So it is going to be 2 4 ja 8 and 2 2 ja 4, 2 2 ja 4, point how after how many digits, 2 digits, so that is 4.48. So 4.48 means 4.48, there is none of the none, no option is matching here. 22.4. 2 4 ja 8, 2 2 ja 4, 2 2 ja 4. It is from your book only. Okay, I've selected Pearson book. They have given the wrong option. Okay, actually it should be 4.48. Some mistake is there. Option number A is correct. 4.48. Okay, and here is 2.48. 8.68 you can mention, but the correct option is option number 1. Can you understand this one?
Yeah.
Okay, good. Can I erase this?
Yeah.
Okay, good. Type 3. Okay, type 3. Okay, so type 3, they are saying how to calculate the type 3. Calculation of, they are saying calculation of total number of atom, total number of atoms, calculation of total number of atoms in gaseous volume, gaseous volume. So how we calculate? So that is N is equal to, we have to apply what formula, N is equal to, you know very well, that is small n into Na. Okay, so what we can write, N is equal to the for gaseous volume, what is there, given volume upon 22.4 liter into Na. This is what, so this is what the N value, but total number of atom N is equal to, so what we can calculate, atoms in one molecule, atoms in one molecule, we have to do atoms in one molecule. Okay, atoms in one molecule multiply by given volume upon 22.4 liter into Na. So this is what the complete formula, or you can say that is number of atoms. If anyone is asking number of atom, so what we can do, that is atomicity. This is going to be atomicity multiply by given volume upon molar volume means 22.4 liter into Na. So can you understand this problem? This equation formula is all about.
I'm trying to think. Wait.
See, N into Na, this is N into Na means what? Total molecule. This is what?
Yeah.
Total molecule. Okay, this is total molecule. Of total if you are calculating total molecule, so it will become the number of atom. Number of atom. Okay, number of atom. So this is common for gaseous system. For gaseous system, if it is the gaseous system, for it is the gaseous system, so what you will do here, so N is equal to N value, small value, how to calculate, given mass upon 22.4 liter, just now we have done here.
Yeah.
See here, N value, how you are calculating, given volume upon 22.4 liter. No, here you see
Okay.
N is equal to given volume upon molar volume, means N is equal to given volume upon 22.4 liter. So that is what we are doing. So here also the same way. Now that is one molecule can have so many atoms, right? One molecule can have so many atoms. So that is atomicity, then N into Na. Is it now okay?
Yes.
Okay, thank you. So can I erase this one, or are you writing the formula? Written.
No, I wrote it already.
Written, na? Okay. Questions. Calculate the total number of all type of atom. Calculate the total number of all type of atoms present in they are saying present in let me check, that is how much volume they have given. Let me 1 second. I'm checking in the book. I got 179.2 liter of 179.2 liter of CO2 gas. They have given 170 of CO2 gas. So they are asking. So how can you solve a option they have given? Option, if you are writing, option they have given. Okay, firstly you try to calculate it out. What we have to do?
So we have to first calculate the number of moles.
Yes.
We have given volume over molar volume. So we have
Yeah, you take time, nothing to hurry and nothing to worry. Okay. How much is coming?
8. 144 times 10 to the power 23.
Yes. Good. Super. So you now started understanding this type of problem. So this is 144.528 into 10 power 23 atoms. Understood? Is it okay?
Yeah. Yeah.
Okay, thank you. So can I erase this?
Yeah.
Now see, that is this many type is there, not more type are not there in this case. That is the, if I am talking about this one, this many types are there. Let's try to understand another concept, stoichiometry. METRY. What is stoichiometry? Have you heard previously in 10th lower classes? Have you heard this name?
Yeah.
What is this?
Well, it's what we've been doing is how to use these concepts to calculate the different values, I would say.
Yes. Good. See, stoichiometry, there are so many definitions you will find, but one basic definition is what? That is the mole concept in, mole concept in equation. Mole concept in equation. Mole concept in equation is known as stoichiometry. Is known as, this is one more term is there, valence equation. Okay, mole concept in valence equation. Valence equation. Mole concept in valence equation is known as stoichiometry. Now that is how much amount of, that is how much amount of, they are saying how much amount of product form in a reaction, product form in a reaction, or how much reactant consumed, how much reactant consumed. Okay, consumed in a reaction is known as stoichiometry. Reaction is known as stoichiometry. Is known as stoichiometry. This is what, okay, meaning that is if mole concept you are applying in a reaction and they are asking that is 20 gram of CO2 are reacting with this many gram of something. So how much amount of the subproduct is formed? This type of reaction when you are going to study, that is what is known as stoichiometry. Are you be able to understand the meaning of stoichiometry, what I am telling here?
Yes.
So stoichiometric, the basic meaning is there, that is how much amount of any product is going to be formed in certain reaction is known as what? Stoichiometric. So let's try to start from the very basic problems. Okay, so I'm giving you just, can I erase this one?
Yeah.
Okay, let's write down question. I'm writing the question, I'm explaining with the help of question, and the same way you can frame the concept also. The question is there, if 16 gram of CH4, CH4 name is methane, if you are knowing that is CH4, 16 gram of CH4 is, they are saying burnt, it is going to burnt completely with CO2, completely with CO2, no, with O2, sorry, with O2 to form CO2, to form CO2. Okay, then
Okay.
find the, they are saying find the mass of CO2 produced, mass of CO2 produced, they are saying. So what they are saying, equation they have given. Okay, again I will teach you after 1-2 class, I'll teach you how to balance the equation. Okay, but by the way, here the equation will be given. Here is CH4 is there and that is O2 is there. Simply how to balance this equation, one carbon is there, so one carbon dioxide, and here is 4 hydrogen is there, so that is it is going to be 2H2O. So see, carbon is here one, both side equal, hydrogen 4 here, hydrogen 2 to the 4 here. Oxygen is not balanced, here is oxygen is 2 and here is 2, so we can multiply by 2. So by the way, this equation is given here in the question. Option also they have given 44 gram, B number they are saying 22 gram, C number they are saying 11 gram, and D number they are saying none. So let's try to solve solution. How can you do, Mika? See, they are saying if 14 gram of CH4 is burnt completely with O2 to form CO2, then find the mass of CO2 produced. Okay, what they are giving and what they are asking, it's very difficult. So see, So CH4, that is mass of CH4 they have given. Mass of CH4 they have given. Okay. So how much mass they have given? Simply they have given mass of CH4 is how much? 14 gram. No, 16 gram. Mass of CH4 is 16 gram. So number of mole we have calculated. Number of mole of CH4. So how much will come? Given mass of over molar mass. So given mass is 16 gram. What is molar mass of CH4? Calculate. Carbon is 12, hydrogen is 1. So how much will come?
16.
16, yes, thank you. So this is going to be 1 mole, right? So it means here CH4 is there, only 1 mole is there. Okay. So how many mole here CO2 is forming? This is also only 1 mole, yes, na? See, with the help of his coefficient, 1 mole is here, 1 mole is here. It means 1 mole CO2, no, 1 mole CH4 gives what they are going to give? Gives 1 mole CO2. 1 mole CO2 means 1 mole CH4 gives 1 mole CO2. Yes, yeah, no?
Yeah.
Okay, very good. So 1 mole CH4 gives 1 mole CO2. It means what we can do. It means what we can do. So N is equal to given mass over molar mass. NCO2 is equal to given mass of CO2 over that is molar mass of CO2. Yes, yeah, no?
Yeah.
So N is how many mole? Already you are saying 1 mole. And here is the mass is there, given mass divided by molar mass CO2. Can you calculate how much will come? Carbon is 12, oxygen is 16. So how much will come? 12 plus 2 into 16. How much is coming?
16, 32, 44.
44 gram per mole. So it is coming 44. So cross multiply it. So mass will come how much? 44 gram will come. Yes, yeah, no?
Yeah.
Got the answer?
Okay.
Yes, yeah, no?
Yeah. Okay.
It will be quite difficult only. It will be quite difficult. Don't think that much of easy. It's quite difficult.
Number.
Can I erase?
Yeah.
Okay. Let's try to write the one more problem here. Question I'm giving you. It's very difficult to sit 1 hours na? In front of the system. 1 hours is very difficult. Here in India, it's online classes now. So students are there in one class, 150 student, 50 student are there, 150 student, 140 students are there here admitted. But in online classes, how many are joining? How many? It's around they are joining 50 student, hardly 50 student, 55 student. Out of 150, hundreds are absent. Hundreds are absent. No, online classes means sitting this many hours and connecting what the topic content is being delivered. It's very difficult. If you are to so many students, the teacher cannot connect all of you. Okay, all of them they can't connect. So one-to-one is okay. One-to-one is okay. We can discuss. But when there is so many students are there, where the one student is facing problem, teacher don't know. So that ultimately it will become headache to the student, and the student shut down the laptop and they are sitting. Okay, I'm giving you one question. They are saying CaCO3 equation they have firstly given, giving CaO and CO2. Okay, in this equation, in this reaction, they are saying in this reaction, they are saying find the volume of, in this reaction, find the volume of CO2 produced. Find the volume of CO2 produced. They are saying find the volume of CO2 produced when 50 gram of CaCO3 is decomposed. See how the decomposed DECOMPOSED. How difficult this problem is looking, but the problem is very, very easy. Okay. Calcium mass they have given. Calcium mass they are saying 40. Carbon is 12. Oxygen is 16. This is given. Option they have given 11.2 liter. Next one is 22.4 liter. 44.8 liter. And last one is none. This is what the question. Here is the A, this is the B, this is the C, and this is the D. Okay. Now, first of all, what we have to do, moles of CaCO3 we have to calculate. Moles of CO3. So if I'm asking, so moles of CaCO3, moles of calcium carbonate, CaCO3, it will be given mass over molar mass. So given mass is 50. How much is coming molar mass, Mihika? Can you tell me?
Wait, I don't know. Calcium.
40.
Oh, okay. 40, carbon 12, and oxygen 16. So 40 plus 12 plus 16 times 3. 100?
100. Yes. Good. Your mathematics is nice. Okay. So it is going to be 100. So it is coming 0.5 mole. Yes, yeah, no.
Yeah.
Okay. This is very, very tough. I know, very tough. I know, and this question is concept building. That is called, this type of question is what I am giving you, concept building question. This is the concept building. Okay. See, and again I will teach you, because no, it takes a little bit time. I need to teach you limiting reagent also. I will teach you limiting reagent later on. I'll teach you in this chapter only. So here you see, this is the what we are going to understand here. So according to equation, here nothing is there means one is there. Here is nothing is there, one is there. So 1 mole, okay, CaCO3 gives, how much is there giving? Gives 1 mole CO2. Yes, yeah, no?
Yeah.
Now, but in the question, it is the equation. It is according to equation. We are just thinking that it is 1 mole CaCO3 is there, and 1 mole CO2 we are getting, because the coefficient is 1 mole. Now, how much we got? Actually, how much? They have given 50 gram. 50 gram means how many mole given? 0.5 mole. So if it is the 0.5 mole, therefore, what we can write? 0.5 mole CaCO3, 0.5 mole CaCO3 gives how many? How much it will give? If 1 mole is giving CaCO3, 1 mole CO2. So 2 mole will give 2 mole CO2. So 0.5 mole CaCO3 give how much mole of CO2? Can you tell me?
0.5 mole.
0.5 mole CO2. Thank you. If you understand this one, my work is over. If you understand this much, that is, my work is over. This I was trying to explain to you. So if you understand this will be, that is 0.5 mole CO2 will form, because the amount is 50 gram. But balancing equation have nothing relation with the how much amount is given. I know actual amount we don't know. Equation gets balanced according to its own balance sheet. But how much amount is given, I know that proportion the product will form. That proportion, that is what about the stoichiometry. Now here you see, they are asking volume. So one mole gas volume, if I am writing, it is 22.4 liter. Yes, yeah, no?
Yeah.
So therefore 0.5 mole CO2, okay, will be how much? 0.5 into 22.4 liter. Yes.
Yeah.
So it will be how much? 11 point how much? 2 liter. CO2 will form. If you multiply by 0.5, now it will come 11.2. So correct
Yeah.
answer is option number 1. Are you be able to understand this?
Yeah, I think so.
You think so? Okay. It is, although it's tough, not very easy. Very easy. If you give me 5 minutes more, I'll solve one more problem.
Yeah, okay.
Otherwise, it is up to you. If you don't want, we can study in next class.
No, it's okay.
Okay. So can I erase this one?
Yeah.
Okay. Let's try to read one problem. They are saying 2C4H10 plus 13O2. They have given. They are saying 8CO2 plus 10H2O. This is also concept building problem. Concept building problem. Okay. So here see 2C4H10 plus 3O2. It is giving 8CO2 plus 10H2O. This they are giving. And they are saying find the mass of CO2 produced. Find the mass of CO2 produced. Mass of CO2 produced. Mass of CO2 produced when 5.8 gram of C4H10, okay, is burnt. BURNT. So they have given option A number option. They are saying 19.6 liter. They are 19. CO2. They are saying find the mass of CO2. So 19.6. B number they are saying 17.6 gram. D number they are saying 120 gram. Okay, and E no, this is the C actually, and D number they are saying that is 40 gram. Okay. So how can you do solution literacy? Solution. How many gram they have given? First of all, this equation have the relation, okay, but first of all, they according to the equation, if you are going according to equation, what we can do according to equation, 2 mole, because here is how many there? 2 mole is there, na? 2 mole C4H10 gives how many mole it is giving CO2? How many mole giving?
8.
Gives 8 moles CO2. 8 moles CO2. Okay. So if I am asking 1 mole C4H10 gives, how many moles it will give? If 2 mole giving 8, so 1 mole give
4 moles.
how much?
4.
4 moles. Thank you so much. So it is 4 moles CO2. Now see. How many moles given according to questions? Okay. So see, according to question, given mole, how many given mole are there? Given mole is equal to given mass upon molar mass. So given mass is how much is they have given? 5.8. 5.8. How much will be molar mass? Can you please tell me? C4H10 molar mass. Carbon is 12, hydrogen is 1.
12 times 4. Oops. 48 and then 20. So 68.
See?
Oh, it's 10 hydrogens. Okay, 58. Sorry.
58 gram. So if you divide this one, so it is coming, how much it will come? It will come 0.1 mole. Yes or no? It's going to come 0.1 mole. Is it 0.1 mole? Yes, 0.1 mole. So I'm erasing. I'm erasing. So see, 1 mole is giving 4 mole CO2. So 0.1 mole, 0.1 mole C4H8 gives how many moles it will give CO2? Tell me. If 1 mole is giving 4 mole, so 0.1 mole gives how many?
0.4 moles.
0.4 moles. Thank you. Oh, great. 0.4 mole. Okay. So 0.4 moles they have given. So that is you can apply N is equal to what? Given mass upon molar mass. So N value they have given how much? 0.4. Given mass they are asking. Molar mass CO2, just now you calculated CO2. If you memorize, that is carbon is 12 plus 2 into oxygen is 16. So that is it will be 12 plus 2 into 16. So it is 12 plus 32. So it is 44.
44, yeah.
44. So this is there. Here is the equal to sign is there. So if I am asking, that is how much given mass will be there. Can you calculate? So here is given mass is equal to 0.4 into 44. So if you solve, it is coming 4 4 ja 16. 4 4 ja 16, 117. Decimal after this one. So 17.6 gram. This is the given mass. So correct option is option. This is the what the type of problem. I'll share you the problem. Okay, late night today I'll share the problem you solve.
Okay.
And what the problem you are not able to solve previous lectures, that you send me.
Yeah.
If you are solving, if you are having some other book also, if you are solving, there is no problem. Okay, so anytime, anytime you can send me. Whenever I'll get the time, I'll reply you back. Okay.
Okay.
So this is all about today. Okay. Can you wind up?
Yes.
You wrote this one or not? This one problem.
No, I actually did not write it. Should I write it?
Not needed that much. If you understood, means that's okay.
Okay.
So okay. By the way, I'll share you the video also. No problem.
Okay.
Okay. Bye. Take care.
Okay. Bye. Thank you.
Welcome.